So now we're going to be getting into maybe my second favorite thing from this entire class, and that's electron configuration. But in order to get there, we have to talk about a couple of different kind of rules. So at this point, we've talked about basically where electrons can be, what different quantum numbers are, what are our four different quantum numbers. We've really focused on three quantum numbers. We're going to get our fourth one right now. But in order to do that, we have to talk about a principle or an idea known as the Pauli exclusion principle. Now, the Pauli exclusion principle states that no two electrons in an atom can have the same set of four quantum numbers. Therefore, an orbital can hold a maximum of two electrons, and they must have opposite spins. And this is really just a way to introduce our fourth quantum number, and that is our m sub s quantum number. Now, that m sub s quantum number, that can have two possible values. The m sub s quantum number, the magnetic spin quantum number, can either have a value of plus 1/2 or minus 1/2. And once we get into electron configuration a little bit more, I'll go into that a little bit more and describe those just a bit. But what that means is basically every single electron within an atom has its own designation, has its own set of quantum numbers. That's a really important thing to keep in mind. The next idea, or the next rule that we have to follow, is what is known as Hund's rule. And Hund's rule, the Pauli exclusion principle and Hund's rule, they're always kind of grouped together, and so people have a tendency to get them mixed up. Now, they describe different things, and they're taking kind of different approaches to explain different principles. So the Pauli exclusion principle, every electron has their own set of quantum numbers, whereas Hund's rule is really just it relates to energy. And so Hund's rule says for degenerate orbitals, the lowest energy is attained when the number of electrons with the same spin is maximized. Okay, so we just talked about our magnetic spin quantum number, our m sub s, but we haven't really talked about spin of electrons. Now, what that ultimately means is every single electron has a different energy level. So those electrons that are closest to the nucleus are your lowest possible energy. As electrons get farther and farther out from the nucleus, they get higher and higher energy. And we can see that kind of visualized with this energy diagram. Okay, so this shows our increasing energy level. That's what the E here is, and that arrow pointing upward. Okay, so when you think about an atom, you have your nucleus, and then you place your first two electrons. And those two electrons are going to be placed in what is known as the 1s orbital. So that 1s orbital has two electrons, and those two electrons are going to be displayed with different directions. Outside of the 1s orbital, you have the 2s orbital. Then you have the 2p, the 3s, the 3p, the 4s, and now, well, we could go on from there with the 4p orbital, but let's go ahead and start looking at these electrons. So when it comes to spin or m sub s values, I always think about the plus 1/2, meaning pointing up. So one electron is going upward. What does that mean for the other electron? It's going in the opposite direction. So those two electrons are going in opposite directions, so they're not going to be basically going in the same direction. Instead, they're two cars passing in the night. Okay, so when we talk about Hund's rule as it affects the 1s orbital, we've got one electron going up, one electron going down. Okay, now the next two electrons that we're going to place, how does the energy level of those electrons relate to the 1s orbital? Well, that energy level is a little bit higher. Okay, but the same thing with respect to Hund's rule applies. One electron's going up, one electron's going down. The 2p orbital. Okay, now the 2p orbital, let's think about what that p orbital looks like. Our p orbital, that's our dumbbell shape. And when we think about that p orbital, we had possible values. So think about those L values, or those m sub L values of +1, 0, and -1. So you could look at this as the p sub x, p sub y, and p sub z. One of these is positioned about the x axis. One of them is about the y, and then one of them is about the z. Each one of these can hold two electrons. Okay, so we're talking about the 2p orbital what we are going to do is we're going to basically place these electrons as far from one another as possible. So think about this first electron that we placed as being in the p sub x. This is in the p sub y, and this is in the p sub z. Okay, so if we put one electron in the px, one electron in the py, and one electron in the p sub z, they're all going in the same direction. So we've maximized the same spin, and those electrons are far away from one another as possible, which is good because when you think about electrons, what is the charge of an electron? It's negative. So what do we know about two negative charges? So two electrons. Well, they're going to be repelling one another. So we want to get them as far away from one another as possible so they're not repelling anything or each other. So this right here is a nice display of Hund's rule. Our 1s and our 2s orbital, we have got two electrons in each of those. They're going in opposite directions. They're happy. Okay. Then that p orbital, what we wanted to do was we wanted to place these electrons as far away from one another as possible. Done. And we wanted them all to be going, or we wanted to maximize our spin. So we have them all pointed upward. So when it comes to number of electrons that we've placed a total of 7. Where would we put our 8th electron? Well, our 8th electron would go into the 2p sub x orbital. Okay. Those two electrons in our p sub x, they have opposite spins, so that's good. Now the p sub, so if we put our 9th electron, well, that would be the p sub y and then the p sub z. Okay, I think some of this, one of the complicated things about electron configuration is it's really helpful to read about these principles and rules, try a practice problem, then come back and try to basically reconcile the information over and over again. It takes practice, but it is kind of abstract, but it, I think, is something that can kind of make sense, and once you understand those rules a little bit better. Okay, so there we go. There's our p sub y or p sub z. The next electron would be in the 3s. There we go. Okay, now I'm going to go ahead and pause right here. I'm going to make another video where we go into electron configuration a little bit more. All right, thank you very much.